Good morning, Barcelona. How are you guys doing? Come on, I have audience participation later, so you need to actually answer that question. How are you doing? I'm just thrilled to be here. I got the chance to come to this conference last year and loved it so much that I wanted to come back this year. And I'm stoked to be representing Strava and tell you a little bit more about our journey. So my name is Jason, and I'm engineering manager at Strava. Most of you probably have heard of Strava or even are a user. But in case you don't know what Strava is, our mission, there we go. Our mission is to connect athletes to what motivates them and help them find their personal best. Our goal is to be the record of the world's athletic activities. We're doing this through one main product, which is a web and mobile app that allows athletes to get insight into their athletic activities, as well as get connected with athletes near them for some friendly competition and camaraderie. Earlier this year, we hit several milestones, which we are very proud of as a company. We now have over 2 billion activities uploaded from over 42 million athletes. And my favorite stat of all is that 82% of our athletes come from outside the United States. We are a company of about 200 people, so the scale at which we operate around the globe is quite large for our size. I've been at Strava for about 4 years now. But before moving to the United States, I was actually born and raised in South Africa. And outside of my aspirations as an engineer, I actually really want to open up a restaurant someday. In fact, the inspiration for my restaurant idea comes from a cafe that I've stumbled upon in Barcelona 4 years ago. So if you are a foodie, please come talk to me afterwards, and I'll tell you all about my idea. But enough about me. Let's get into that audience participation I was telling you about. So can you raise your hand if you have ever had an idea of how to improve the product you're working on? If you don't raise your hand, you should probably leave the conference. Raise your hand if someone told you, that idea sucks. I don't think it's going to work. All right. Raise your hand if you thought that person was wrong. Yeah, okay. Now you have to be honest with this next question, okay? Raise your hand if you ever told someone, your idea sucks. I don't think it's going to work. See, the problem with this line of thinking is the phrase, I think. However, I think is not a very scientific way to make decisions about what we're building. When we say I think, we're assuming that we have perfect empathy for our users. But our users are diverse. They're unique. They're different. They come from all over. So why do we think we know about what they need? Here's a really good example that happened to my team really recently. We were tasked with building a screen to encourage new athletes on our platform to take a trial for our premium product. So we got into a room and we brainstormed a bunch of ideas. The first screen was our first idea, find your sweet spot. We have this really cool feature that helps athletes figure out if they're training too much or too little. This seemed like something that new athletes on our platform would want. The second idea, commit and conquer, was encouraging users to take a trial because of our goals feature. Now, we know athletes have goals. They're always striving to do something next. So we thought this was a really good idea. And then the third idea was see how you stack up. It's a leaderboard feature that allows you to see how you are doing compared to others in your same age or weight categories. Now, we really liked the first two ideas, and we weren't so thrilled about the third idea. But we had about a week to build this test, so we got to work. Fortunately, at the end of the week, we had only built the first two screens, and so we were going to ship an A/B test that had those two screens. But because of some other factors, the deadline got extended by 3 days, and so we got to build the third variant. When we shipped this test, the first two screens, which we were stoked about, had no impact on the athletes. The third screen crushed it, knocked it out of the park, and we were so surprised. We had been building a lot of screens like this, and we thought we knew what we were doing, but clearly we weren't. It was a good reminder that I think is not the best way to make decisions about what you're building. So how can we remove bias from what we build and learn what our users actually want? The answer should be obvious by the title of my topic, but the answer is A/B testing. Now, I know all of you have probably heard of A/B testing and know how it works, but A/B testing wasn't invented recently by some tech company. It actually goes back far, far long ago. So meet James Lind. He's a British naval doctor. Fortunately, James Lind's job is to travel on ships from England to different parts of the world, trying to keep sailors alive. But James Lynn's not very good at his job. A lot of sailors get scurvy and die. So on one of his ships, he decides to run what is now recorded as the first A/B test ever. He has 12 sailors on board, and they contract scurvy. So he divides them up into 6 groups of 2 and gives them different diets. You will be surprised by these different diets. So some of these sailors get a quart of cider. Some of them get 25 drops of sulfuric acid. Some get 6 spoonsful of vinegar. That's looking pretty good right now, isn't it? Some poor chaps get half a pint of seawater. 2 very lucky guys get 2 oranges and a lemon. And 2 guys get a spicy paste. Literally in his journal, he writes a spicy paste and does not go into detail. Now, as we know from history, scurvy is solved with vitamin C, which comes from citrus fruits, like 2 oranges and a lemon. So this is just a fun reminder that A/B testing has been around for a while, and it's a tool that can help you scientifically determine which solution best solves your user problem. When I joined Strava 4 years ago, A/B testing wasn't something we really did. In fact, the year I joined, we had about 5 experiments we ran at a company of about the size of 80 people. The next year, that increased to 25 experiments. And then this year alone, we've already hit 300 experiments, and we'll do about 600. Now, the company has doubled in size, but the number of experiments has grown exponentially. Now, you can't just decide suddenly that you want to run more experiments and just do that. You need to scale your infrastructure and your processes to support that kind of growth in experimentation. So let me take a few minutes to tell you exactly how we did that. You can divide experimentation into 3 kind of steps. You have the cohorting step, which is how you determine what users will see. You have the reporting step. How do you know what happened in a test? How do you know what users did? And the third, you have the process. How do you go from an idea to actually shipping and learning from your test as quickly as possible? So let me just explain to you in each of the areas how we innovated to support such large amounts of experiments. First, in the cohorting step. In 2015, we were using a product called Optimize for mobile experiments. Optimize is a great out-of-the-box solution that works really well. But in 2017, we wanted our mobile microservice architecture to also be allowed to do experiments. So we needed a backend solution, so we built our own in Scala. Then in 2019, we decided to replace Optimize by extending our server-side cohorting to work on as well on mobile. It was becoming too heavy to introduce new engineers of the company to 2 different tooling for the same purpose. Plus, by building it in-house, it allowed us to build features that were very specific to Strava. For instance, we can cohort athletes into a test if they have only like 5 followers or less. And that's harder to do with a third-party tool. The next is reporting. And reporting can really be thought of in 2 steps. There's product analytics and there's business metrics. On the product analytics side, before 2015, we were using we had tried a myriad of different analytics platforms. We tried Mixpanel and Flurry. And in 2015, we wanted to instrument our feed with a high fidelity of detail. Now, data consistency was really important to us. We wanted to know how our Android, iOS, and web feeds operated. And so we chose Google's protocol buffer technology to provide data consistency among our 3 platforms. Now, unfortunately, if you've ever worked with Google protocol buffers, they're really great, but they're very strongly typed. They require you to update some central repository of definitions and then propagate those definitions to your multiple platforms. Now, this is good when you have products like the feed, which aren't changing that much. But when you're trying to run experiments, waiting a full day to update your definitions for events and waiting for those to propagate to all of your platforms, that just doesn't make sense. Sometimes your experiments you're running take about an hour or 2 to build. So the fact that product analytics take much longer than that doesn't make much sense. So we turned to Segment.io, which is a company that offers attribution and analytics tooling. We were already using Segment for various attribution purposes, and so it was very easy for us to use their analytics tooling. Now, Segment analytics tooling was completely opposite of Google protocol buffers. Google protocol buffers were strongly typed. Segment was loosely typed. It was literally just key value store for analytics. And this was awesome for engineers. It took a matter of seconds to instrument new things in our app all over. Now, when you go away from a strongly typed system to a loosely typed system, you know that you lose the data consistency. On Android, we were using dashes in our names, and iOS, we were using underscores. In one part of our iOS app, we had the same event firing 4 times with slightly different names because each team wanted their own definition of the name. So unfortunately, this wasn't working for us either. So in our third attempt for an analytics system, we built our own using Snowplow's technology. Snowplow uses JSON schemas to allow us to have a relatively loosely typed client API. But what we did is we built a validation service on the back end. So analysts can define exactly what events they are expecting from the mobile platforms. But on the front end, engineers can easily implement using a loosely typed system. So analysts get great data consistency over all the 3 platforms, because us engineers get alerted if we try to send an event that isn't supported, but engineers can move very quickly. And if you'd like to know more about that, please come talk to me afterwards. I love talking about analytic systems, because as you can see, I've tried it 3 times, and hopefully now it's working out well for us. On the business metrics side, sometimes you care more about the business metrics that you're affecting with your A/B test, and less about which button did the user click more. So in 2015 to 18, all of our experiments were analyzed manually by an analyst. For my team at Strava, we care a lot about getting new users to upload their first activity or to follow someone. So when we're running 5 experiments or 25 experiments, it's not that much to ask an analyst to do the SQL queries by hand. But when you're running 300 experiments in a matter of months, analysts are now the bottleneck, and you can't do that. So one of my coworkers, Dave, began building an experiment reporting framework. What this is a dashboard where you can take the name of your experiment, put it in, and immediately have all of your metrics outputted. So for any experiment run anywhere in the entire company, you can see all of the metrics that you have affected. There's no SQL writing to be done. So an engineer or a designer or a product manager can run an experiment, ship it, and analyze it themselves. They have no dependency on an analyst to do any kind of analysis for them. And this has allowed us to move very quickly. It has also created transparency across the company. If I was running an experiment on my team, I would look at my team's metrics to see if I helped them. But I would never look at another team's metrics to see if I've hurt theirs. With this reporting framework, you could easily see your impact of your change over the entire company. And lastly, there was innovation in different processes. Now, obviously, I could spend hours talking about all the processes that we had to change to support this growth, but I want to focus on one in particular. A lot of the features you might use on Strava today were actually built 6 to 7 years ago. So when we've been building features, all the code that was merged was expected to be pretty robust and long-lasting. It was expected to be unit-tested and integration tested. Now, this is great for features that will last a while, but by definition, whatever you ship in an experiment might not work, and so you might want to delete it. So we had this problem with engineers wanting to spend too much time writing robust code when it wasn't the right time to do that. Furthermore, engineers who were doing pull requests were applying too high of standards to the code that was being written. So we came up with these experimental code guidelines, which helped engineers understand when they could cut corners and helped reviewers understand how robust the code should be written. And in 2018, we built a Slack bot to learn on experiment status. One of the big concerns when you're running several hundred experiments in a year is that you're introducing a lot of tech debt. Engineers might introduce an experiment and then forget to remove it. So what we did is we solved this by having Slack bots that alert everyone in the company when your experiment is either running or done or needs to be cleaned up. So from 2015 to 2019, we have scaled how many experiments we're running. But what we learned along the way was that experimentation offers so much more than just helping you make better decisions about your users. And so I want to tell you very quickly about what I call a culture of experimentation. I want to tell you about how I think a culture of experimentation can help you build stronger and more effective product teams. And there are 3 ways it does this. Firstly, a culture of experimentation encourages risk-taking by providing a safety net that promotes learning. Culture of experimentation increases the collaboration and creativity of your team, resulting in better ideas. And thirdly, it promotes leadership and entrepreneurship on the team. So we'll start with encouraging risk-taking. So any good product team starts with user research or analytics data to decide their roadmap. But in reality, any product plan is born out of a set of assumptions as well, which we like to masquerade as intuition. Sometimes our intuition is spot on and we nail it, and sometimes it's incredibly wrong. In the case I showed you earlier, our intuition was pretty wrong. Daniel Kahneman, who's the author of Thinking Fast and Slowly, and a Nobel Prize winner in economics, has studied the science of intuition. And he says that the mere fact that you have an idea and nothing else comes to mind, and you feel a great deal of confidence, absolutely does not guarantee accuracy. So I know what you're thinking right now. It sounds like I'm just saying, we don't know what we're doing. Product development is just a guess. And that's not what I'm saying. All I'm arguing is that it's important to differentiate what we know about our users and what we don't know. And when we do that, we can set up experiments to increase the learning. See, a culture of experimentation encourages learning about whether those assumptions about your users are correct or not before heavily investing in a final solution. In a culture of experimentation, the goal is learning. A/B testing is not just figuring out which button or which page looks better. It's about learning about your blind spots about users, what you don't know. Because learnings will go much further than just simply knowing how a button did. Learnings can be applied to future decisions on your team. And when the goal is learning, it's more acceptable to take risks. When we're just solely focused on moving a business metric, there's a fear that you might move that business metric in the wrong direction. And so we take a step back from taking risks, and we enter into a world of incrementality. So what happens when you take risks and you don't prioritize learnings? Well, luckily, Snapchat has a great example of this. About a year ago, Snapchat unveiled a brand new redesigned app. Now, unfortunately, this did not go down very well for them. They started losing millions of users every month. In an internal memo from Evan Spiegel to his employees that was later leaked, Evan Spiegel says this: "We rushed our redesign, solving one problem but creating many others. Unfortunately, we didn't give ourselves enough time to continue iterating and testing the redesign with a smaller percentage of our community. As a result, we had to continue our iterations after we launched, causing a lot of frustration for our community." John Constantine of TechCrunch says, "Evan Spiegel always went with his gut rather than relying on user data like Facebook. Aging further and further from his core audience, he misread what teens care about. At one point, Evan Spiegel's intuition was spot on, and then it wasn't. Evan Spiegel's mistake wasn't that he took a big risk, it's that he didn't test those risks. He didn't test his assumptions, and that's what happened. Now, most of us don't have the freedom to take big risks like Evan Spiegel. But if our product teams solely focus on moving business metrics, we will be paralyzed by the fear of failure and hinder innovation. But by replacing the fear of failure with the opportunity to learn, experimentation provides a safety net that encourages teams to take risks." The second way culture of experimentation can help you build better product teams is by increasing the collaboration and creativity of your team, resulting in better ideas. And this sounds very much like the talk you just heard, which is awesome. So a lot of us are used to this version of product development, where someone defines requirements, then someone designs the solution, then an engineer gets the solution to implement, and then we measure what happened out in the wild. Now, this version of product development, called handoff waterfall development, is quite structured. It implies that the project has to be fairly well defined as it goes through these various steps. So by the time you get down to the implement solution, well, you don't really have a lot of time to be able to add your ideas. In fact, it's so structured that we have created roles specifically for this system. We have a product manager whose job is to determine what we build. Then designers take that determination and decide how it looks and behaves. Then an engineer builds what has been determined, and an analyst measures what we ship. Now, if you're an engineer further down this process, there's no space for you to collaborate or for you to add your ideas. Your job is to build what you were given. But this doesn't really make sense, right? In reality, it is everyone's responsibility to ship great products to users. You might be a designer, you might be an engineer, but at the end of the day, our job is to ship amazing things to our users. If you're a designer, you should care about the performance of the app. You should care about if it's robust or if it crashes a lot. If you're an engineer, you should care about the usability of the product. So on my team at Strava, we do things a little differently. The product manager isn't responsible for determining what we build, but rather for defining the user or business problems we're trying to solve. After that, we get into a room and we brainstorm potential solutions. We develop hypotheses and we define requirements for the experiment. By the time we get to implementing and designing the solution, everyone knows what we're building and, more importantly, why we're building that. Everyone has had time to add their inputs and opinions. Now, I know what you're thinking is that this isn't unique to just experimentation, and you're correct. But I think experimentation can uniquely increase the creativity and collaboration of your team. And this builds off of the last point. A culture of experimentation values a willingness to try ideas you might not have tried before with the goal of learning. Culture of experimentation acknowledges that everyone has ideas on a team, and we should try all those ideas. See, experimentation gives us more reasons to try new things and fewer reasons to say no. When the goal is learning, you want to learn as much as you can about a user. You want to try the most diverse set of ideas because you're trying to maximize learning. It's easy for one or two people on a team to be the gatekeeper of good ideas. But since we know that intuition only gets you so far, why would you let only a few people on your team have all the ideas? And if you've worked in these kind of environments, you know that often it's the engineers, the designers that aren't team leads or managers who are working on products that have the best ideas, because they're the ones working on it day in and day out. There we go. We wanted to take this idea to the next level on our team. So one of the engineers on my team, Tim, came up with this idea called Experiments Day. Experiments Day is a day where we stop our regular product development, and everyone on the team gets to work on whatever they want to work on. They get to ship an idea that they've had and push it out to the wild. Experiments Day has 3 rules. The first rule is that the target metric must be a current focus for the team. So we encourage the people on our team to work on something that is in line with what we're already doing. 2, the experiment must be targeted at 10% of users. This allows us to actually be quite risky in what we're trying because there's not a big risk to hurting the core product or core business. And 3, the experiment must be small enough to implement in an afternoon. This allows us to ideate quickly and collaborate with the whole team. Now, how does it work? Well, one of the engineers on my team, Annie, had graduated college a few months ago, so she was new to the team. She had this idea to change the follow button to say follow back if you were going to someone's profile that already followed you. Now, analytics would say that this wasn't the strongest idea. 80% of follows are reciprocated already. So if I follow you, there's an 80% chance that you already follow me back. But because of Experiments Day, Annie had the freedom to try her idea. So Annie tried this idea, she shipped it, and in 17 days, we had 27,000 new followers as a result of this experiment. Now remember, this was an experiment on a very small population of our users. So when you roll this out to everyone, this was one of the best performing experiments we've ever had at Strava. And not only that, this influenced a series of new product enhancements down the road, all because someone who was a few months out of college was given the freedom to try an idea that was all her own. Thirdly, a culture of experimentation promotes leadership and entrepreneurship on the team. A few years ago, an internal team at Google was tasked with the question, what makes a Google team effective? The hypothesis was that it was probably the teams that had the most experienced people, or perhaps the people with the highest degrees. But instead, they found the complete opposite. It didn't matter who was on the team, but it mattered how they operated. It mattered how they communicated with one another. More specifically, they discovered that psychological safety was the most important factor in determining a team's success. Psychological safety is a sense of confidence that the team will not embarrass, reject, or punish someone for speaking up. It's the shared belief held by members of a team that the team is safe for interpersonal risk-taking. A culture of experimentation that encourages risk-taking, trying new things and ideas from everyone, is a culture where psychological safety can grow and flourish. When you're encouraging everyone on your team to be part of the ideation, to see problems and figure out solutions, you're encouraging them to do that internally on your team as well. You're encouraging people to have a voice, to be action-oriented, to have agency of change. A culture of experimentation is a safe place to allow team members to step up and be leaders. It's a place where failure is really just an opportunity to learn. And that is so important to building a strong team, where everyone feels valued and that they have an impact on what your team is doing. So I hope I've convinced you a little bit that A/B testing is not just a great tool for determining what to build for your users, but it's a great tool for helping you build a stronger and more effective product team. Now, I know a lot of you are not perhaps on a cross-functional team. Perhaps you work in a design studio or an engineering studio, or you're a freelancer or contractor. So I want to leave you with 4 principles that come from a culture of experimentation that I think if you embody will have a massive impact on how your team operates. So please remember that everyone has the right to be creative and to be a leader. Be slow to judge others' ideas. Be quick to collaborate with your teammates. Be quick to figure out, instead of saying, I think your idea is wrong, think, how can I make that idea stronger and more successful? And last but not least, remember to take risks and be willing to try new things. No matter what teams you are on, these 4 things can apply to you. Thank you so much. If you would like, we have questions now, but if you would like to follow me or contact me, feel free to use any of these addresses. But of course, follow me on Strava if you use Strava. Thank you so much.
Okay. Thanks, Jason. We're going to take a couple questions again, so if you go to the link, and don't forget to upvote as well, so I all know what you're all interested in. And the more questions we have, the better, so just keep them coming. The first one is, I think, a really interesting one, is how do you not A/B test yourself away from a product vision? How do you keep your product cohesive while doing all these different tests?
Ooh, that's a tough one. So I think it comes down to, again, centering yourself on what you are trying to learn about your user. So if you have a product vision, you have a general sense of what you think the problems you're trying to solve at a high level. And I think you need to break that up into the individual assumptions and things you want to test along the way. So instead of testing a specific feature, like materialization or a specific kind of UI, you want to think about what are the biggest risks and things that are unknown in my product vision, and how can I test my way into that? So I think that's part of it. I think the other part about like taking risks, if you only tested button color over and over again, you're fundamentally not learning anything about your users. You're learning where the orange or green works better, and that's been done a million times. So if you actually want to learn about your user, you need to take bigger leaps with A/B testing.
And have you had an experiment that was where you took a big bet and it didn't play out at all? And what did you learn from that?
I've been on the growth team at Strava for 4 years, and famously, none of my ideas ever work. It's everyone else's ideas that work, which is very unfortunate. I think early this year, we unrolled a brand new onboarding flow for new users. So we had this big hypothesis, and we unveiled it. And a company our size, we have many metrics that we're looking at. So we took this big bet. It was about 6 to 8 weeks of work. We rebuilt, I think, something like 22 screens all over the app. And in some ways, it was a success. But in some of our metrics, like new users taking a trial, it was a complete failure. We actually lost the company a lot of money in that trial period. And a lot of people were concerned. They were like, you have lost a lot of money. And I got an email telling me how much money I'd lost. But what did we learn? We learned what users were trying to do in their first few seconds and minutes on Strava. We learned what they wanted to do 7 days later. And that was so important for creating the vision for what we're doing now in the second half of the year. I can't go into specifics, but it was actually super valuable. The amount of money that we, quote, lost was easily made up with the amount of things we learned about our users.
Do you think the people that were originally telling you, there's a fire, we're bleeding money, were convinced 6 months later when the learnings kind of played out?
You'd have to ask them. I think it's hard for executives. It's hard for executives to step back from numbers. It's really hard for them not to look at top-line revenue metrics and growth metrics and see how learnings play in. And that's one of the most important things that we can do as product leaders is helping them see the importance of learnings. I would say most of the executives have kind of come to that side now and are in agreement. But I think what was really interesting in that whole process was helping define more of the outward-facing communication of experiments at Strava. When you're running through experiments, about half of those are going to hurt one team and help another. And so we've had to learn this year how to communicate between vertical teams. And that has been really tough at first. Because I think one of the worst parts about the experiment was that the other team didn't quite know that we were doing it. And that was kind of a learning for me was it's all about internal communication and something we've had to solve since.
And similarly, obviously doing A/B testing slows you down in some ways. So how do you sort of balance that need for speed versus what you're going to learn from doing these tests?
Right. So I'd argue that A/B testing speeds you up. I think if you just go fly by the seat of your pants, you're going to make a lot of mistakes. If it was up to me, we would make all the mistakes, right? Because apparently my product ideas aren't very good most of the time. And so if you think about the number of times you've shipped something and it hasn't gone actually well out in the public, you have to backtrack, you have to rethink it. So A/B testing allows you to make fewer mistakes because you're building this repertoire of learnings as you go. I think one of the interesting things, which if you're an engineer and want to talk more about this afterwards, I'd love to, is that a lot of engineering teams think that like fast A/B testing and cutting corners is inherently bad technological tech decisions, that you're introducing tech debt, that you're not doing things the quote the right way. And there's the famous, the right way is not always the fast way. And I think what we found at Strava is that actually investing in our core technology and our core platforms has enabled us to move faster. So often at the beginning of cycles, we will spend more time investing in technology like a server-driven modular system for our feed and for various pages that allow us to do much more experiments later on. So I think if you make the right investments of your technology, of your design systems, you can actually speed up your process.
And do you actually decide as a group to write code that you might throw away later?
Yes, I would say probably 70% of the code I've written at Strava no longer exists. As a manager, I don't get to code very often anymore, but the other day I opened a pull request purely to delete something I'd written a year prior. So that might not sound the most motivating, but it's actually really cool because it means that we found something better, that we've come out with something that works better, and that's really motivating to me at the end of the day.
Switching gears a little bit, some people are interested in Firebase. Can you talk a little bit about your decision to use a tool or build your own stack?
Yeah, I think you got to remember that Strava's scale is quite large for our size of the company. So we're actually at a really interesting intersection of a lot of external tools are built for kind of the average company, the average size company, the average use case. And then we get to the point where those tools might not be able to support the functionality that we need at our scale, or just the performance. Performance is a really important part of Strava. We operate in so many different countries around the world that external parties, third-party SDKs, often aren't the most performant for us, and we don't have control of that source code. And so we've actually been removing a lot of third-party SDKs just so we can decrease app launch by 200 milliseconds in a country like Thailand or India. That's really important for us. But it's really tough because we're 200 people, which means we don't have giant internal tooling teams, which means product teams are building these internal tools, which as an engineer, I love. I love to get the fact that I get to work on not just a product, but a lot of the internal tools. But it is definitely this kind of weird friction moment of we don't use external kind of SDKs, but we have to support internal tooling.
And especially when you're doing that yourself, how do you decide how long to run an experiment, what the success metrics are, how many multivariates you need, all of those things? How do you set up the test to make sure that it's a good one?
Yeah, so likely how long a test needs to run, there's various schools of thought. You can basically put into a calculator using the minimal detectable effect. So if we think this experiment can move this metric by 2%, you can basically plug that in. You know how many users will be coming to your page, and you can work out that this experiment takes 10 days. So that's one school of thought. The other is that you just wait for your experiment to hit statistical significance. So our reporting framework automatically figures out every day, has your experiment hit something that's statistically significant? And so we kind of run it like that. We kind of wait for our experiments to hit statistically significant. As far as the target metric, we really focus on using input metrics to measure what the user's trying to do versus some like downstream output metrics. So an input metric measures exactly what the user's trying to do in that moment, and an output metric might be some higher level like business revenue metric or something like that.
And do you have data science people who are helping you, or insights folks, or is it really up to the product teams to drive these tests?
All product teams have data science, analytics, everyone internally on their team to help them make these decisions.
Cool. A very specific question about Optimize. No?
Yeah, okay, yeah, sure.
Can you elaborate more on how you use it?
Say it one more time.
Optimize?
Yep.
Can you elaborate more on how you use it in Strava?
Yeah, so we don't use it anymore, but we did use it for a while. Optimize, now they support all platforms. It's a really great, easy-to-use, out-of-the-box solution for A/B testing. It also has internal analytics tools if you want to use theirs versus your own. It's very easy, has a nice GUI to set up your experiment, and those kind of things. So it's really a cohorting tool that can help you determine what users see in your test.
And when you see that one variant is working better, how do you find out why that happened?
That is a really good point. A/B testing can tell you what happens, but it doesn't necessarily tell you why. And you need to be very careful when you're looking at experiments to just assume you now suddenly know why something happened. And that's where user research and interviews and surveys can come in. And those are really useful to determine why. But sometimes it's the pure learning, kind of the larger level learning that's important. But oftentimes we will use user research to dive in.
And have you ever had to work with devices that are maybe not as robust, or maybe offline only, or don't support the typical capabilities that maybe a smartphone or a browser does?
Yes, that is a really good question. There's a lot of reasons why your A/B test might go wrong, or you might get actually the wrong results. For instance, if you're running a test on the performance. So we recently ran a bunch of tests that actually we slowed down our feed and our app launch. We slowed down on purpose to see the impact of slower performance on various markets around the world. So it's called a negative test, because it's much easier to actually purposely slow something down than it is to speed it up. And so it's what we had to make sure that all of our internal tools and cohorting steps and analytics work in areas of low Wi-Fi and low connectivity, right? Because if you're running a test and you're trying to see how maybe an emerging market responds to that test, but your internal tools don't work because it takes too long to load, then, well, that's not good. So our analytics libraries do batches and retries, so we do fancy things like that. Our cohorting tools do a lot of local caching, a lot of retries to make sure that that things work. So we have a high degree of confidence of when a test runs, what actually happened on the phone gets reported back to us.
And how do you basically combine those qualitative and quantitative insights? How do you decide what feedback, whether to go with the A/B test or to go with the qualitative research? How do you make those trade-offs?
Still trying to figure that one out. I think there's always, and it's so important to have a cross-functional group. Every week we have something we call Experiments Weekly in our team, which we get into a room, and the owner of an experiment will put up the experiment on a slide, go through how it went, what you were trying to learn, and then we'll kind of discuss as a group what the outcomes of that experiment are. So it's often a cross-functional discussion that we kind of leave up to the experiment owner to decide at the end of the day what they want to do. So it doesn't matter if you're like brand new to the team or like inexperienced or out of college, like you have the agency to actually make the final decision. And usually, but you have a team behind you helping make those decisions. But I wouldn't say there's any like silver bullet there.
And when you're changing your product a lot through A/B testing, have you seen any impact in the users actually noticing that things just move a lot, or that the app doesn't look like their friends does, maybe anything like that? Have you seen some negative effects just from volume of testing?
Yeah, one of the greatest parts about Strava is that our athletes are very vocal. It's also one of the tough parts. So I have to resist the temptation to go to Reddit every day, because the Reddit Strava is basically just a bunch of people complaining that something has been changed suddenly, and it's everyone trying to figure out, are they in an A/B test or not? Or you go to the App Store reviews and you have someone who's decided to give you a 1-star review a million times. So yes, people notice. I think on average, if you think about your average user is not like me and you. We're not staring at our phone a million times a day and noticing that suddenly something changed. So the average user is not typically a problem, but you do hear about it, and you kind of assume that at scale you have enough users who are doing that, but you also have enough users who are completely oblivious, and you have to tell them about a new feature 20 times before they've ever heard of it.
Someone is asking, is your testing stack open source?
It is not open source. I would love to make it open source when someone gives me the time for it.
And I think maybe two more questions is, one is, when you think about this, knowing that a lot of the code you're going to write is going to get thrown away, how do you budget for that in terms of like delivery times, and also how do you make sure that people understand that that's a valuable investment and not...
Right. So I think one of the most important things you can do, and you're going to hear about this a lot in this conference, is design systems. Creating design systems and also engineering building blocks allow you to invest in the technology that's going to stay around over the course of many different experiments or years, and not keep building the same screens over and over. That's why design system is so important. We have a really great design system for all of our onboarding flows, so that designers on our team don't actually have to design the experiments anymore. They literally say, use this screen and this components from this design system, and go to the copy team and get some copy. And so literally the product manager just drags and drops the various parts of your design system, and it's great. We have modularized and code our design system so that an engineer just takes a view model, basically defines the strings that are going to show up in an image, and drops that in. So the code that we're writing nowadays that's getting thrown away is a matter of 20 to 30 lines. We're not investing in the core screens or the core technology that allows us to move so quickly. We've done things like we've created a whole framework for our onboarding system so that it takes about a half a second to build and run our iOS and Android apps. So that those kind of small innovations help you move so much quicker. So it's really awesome to invest in design systems, invest in engineering components, and those are the fun things as engineers. We get to build tooling to help our teams move faster. So invest in those. Don't invest in making the same screen over and over again.
And lastly, maybe thinking about that there's a lot of people who are more on the design side, how do you actually include everybody in that process? How do you make it a holistic effort for the team to design and run A/B tests, not just something that the data science or product people do? Yeah, so I think the previous talk was so awesome about design sprints. We have a very similar, not quite like that. We've done some design sprints, but anytime we're building something, we always get into a room and we take sticky notes and we just come up with a million ideas. And then we start to sketch out those ideas a little bit. And then we start to agree on the requirements. And then at that point, designers can really take ownership of how does it look and feel. But in the middle of our pod, we have this big pillar in the middle of our pod at work. And anytime you have an idea, you can put on a sticky note and put it on the wall. And then every week, we kind of look at all those ideas and determine what we're going to build next. And we never have a roadmap on our team with these are the features you're going to build at this time for this, this quarter, Q1 or Q2. We have business problems and user problems that we're trying to solve in a time period. So we can take that wherever we want to go as a team, so that if someone has an idea or epiphany some night, we might completely shift directions. We had a new product manager join a few months ago, and we had an experiment come back, and the results were surprising. We're like, we need to run another experiment slightly differently to really learn in this location. And so I was like, great, we'll ship it today. And he's like, wait, what? And I was like, we'll just stop all the work we're doing, we'll do it now. And he goes, it'll only take a few hours to do this. And he goes, you can do that? And he was just so surprised that we had the freedom to be able to stop our work and say, here's a great idea. We need to get this out to the public as soon as possible. And so we have just a great, being able to build that environment on your team is really powerful. You can really move much faster as a result. Great. Thank you, Jason. Thank you, everybody, for the questions.
Thank you so much.